Chandrayaan-3 is a follow-on mission to Chandrayaan-2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. It consists of lander and rover configuration. It will be launched by LVM-3 from STSC Sharn, Sriharikota. The propulsion module will carry the lander and rover configuration till 100 km lunar orbit. The propulsion module has spectro-polarimetry of habitable planet Earth, shape, payload to study the spectral and polarimetric measurements of Earth from the lunar orbit. Lander payloads, Chandra's surface thermophysical experiment, CHAST, to measure the thermal conductivity and temperature, instrument for lunar seismic activity, ILSA, for measuring the seismicity around the landing site, Langmuir probe, LP, to estimate the plasma density and its variations. A passive laser retroreflector array from NASA is accommodated for lunar laser ranging studies. Rover payloads, alpha particle X-ray spectrometer, UPS, and laser-induced breakdown spectroscope, LIBS, for deriving the elemental composition in the vicinity of landing site. Chandrayaan-3 consists of an indigenous lander module, LM, propulsion module, PM, and a rover with an objective of developing and demonstrating new technologies required for interplanetary missions. The lander will have the capability to soft land at a specified lunar site and deploy the rover, which will carry out in situ chemical analysis of the lunar surface during the course of its mobility. The lander and the rover have scientific payloads to carry out experiments on the lunar surface. The main function of PM is to carry the LM from launch vehicle injection till final lunar 100 km circular polar orbit and separate the LM from PM. Apart from this, the propulsion module also has one scientific payload as a value addition, which will be operated post-separation of lander module. The launcher identified for Chandrayaan-3 is LVM-3M4, which will place the integrated module in an elliptic parking orbit (EPO) of size 170 x 36,500 km. The mission objectives of Chandrayaan-3 are to demonstrate safe and soft landing on lunar surface, to demonstrate rover roving on the moon, and to conduct in situ scientific experiments. To achieve the mission objectives, several advanced technologies are present in lander, such as AIC altimeters, laser and RF-based altimeters, though velocimeters, laser Doppler velocimeter and lander horizontal velocity camera, thin inertial measurement, laser gyro-based inertial referencing and accelerometer package chart propulsion system, 800 and throttleable liquid engines, 58 and attitude thrusters and throttleable engine control, electronics, patch navigation, guidance and control, NGC power descent trajectory design and associate software elements, 6 hazard detection and avoidance, lander hazard detection and avoidance camera and processing algorithm, 7 landing leg mechanism. To demonstrate the above-said advanced technologies in Earth condition, several lander special tests have been planned and carried out successfully, viz. Integrated cold test, for the demonstration of integrated sensors and navigation performance test using helicopter as test platform, integrated hot test, for the demonstration of closed-loop performance test with sensors, actuators and NGC using tower crane as test platform, lander leg mechanism performance test on a lunar simulant test bed simulating different touchdown conditions. 1. Mission life, lander and rover, 1 lunar day, tilde 14 Earth days, 2. Landing site, prime 4 km by 2.4 km 69.367621 s, 32.348126 e, 3. Science payloads, lander, 1. Radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, Rambha, 2. Chandra's surface thermophysical experiment, CHA-STE, 3. Instrument for lunar seismic activity, ILSA, 4. Laser retroreflector array, LRA, rover, 5. Alpha particle X-ray spectrometer, APXS, 6. Laser-induced breakdown spectroscope, LIBS, propulsion module, 7. Spectro-polarimetry of habitable planet Earth, shape, 4. 2-module configuration, 1. Propulsion module, carries lander from launch injection to lunar orbit, 2. Lander module, rover is accommodated inside the lander, 5. Mass 1. Propulsion module, 2148 kg 2. Lander module, 1752 kg including rover of 26 kg 3. Total, 3900 kg, 6. Power generation 1. Propulsion module, 758 W2. Lander module, 738 watts, WS with bias 3. Rover, 50 watts 7. Communication 1. Propulsion module, communicates with IDSN 2. Lander module, communicates with IDSN and rover. Chandrayaan-2 orbiter is also planned for contingency link. 3. Rover, communicates only with lander. 8. Lander sensors 1. Laser Inertial Referencing and Accelerometer Package LIRAP 2, Ka-band Altimeter Ka-RA 3, Lander Position Detection Camera LPDC 4, LDAC Lander Hazard Detection and Avoidance Camera 5, Laser Altimeter LASA 6, Laser Doppler Velocimeter LDV 7, Lander Horizontal Velocity Camera LHVC 8. Microstar Sensor 9, Inclinometer and Touchdown Sensors 9, Lander Actuators Reaction Wheels 4 nose 10 nms and 0.1 Newton meters 10, Lander Propulsion System by Propellant Propulsion System MMH plus Moon 3 4 nose of 800N throttleable engines and 8 nose of 58N throttleable engine control electronics 11, Lander Mechanisms 1, Lander Leg 2, Rover Ramp Primary and Secondary 3, Rover 4, ILSA Rambha and Chased Payloads 5, Umbilical Connector Protection Mechanism 6, X-band Antenna 12, Lander Touchdown Specifications 1, Vertical Velocity less than or equal to 2 meters per second 2, Horizontal Velocity less than or equal to half a meter per second 3, Slope less than or equal to 12 degrees 1, Radio Anatomy of Moon-bound Hypersensitive Ionosphere and Atmosphere Rambha Langmuir Probe LP to measure the near-surface plasma, ions and electrons, density and its changes with time 2. Chandra's Surface Thermophysical Experiment CHA-ST to carry out the measurements of thermal properties of lunar surface near polar region 3. Instrument for Lunar Seismic Activity ILSA to measure seismicity around the landing site and delineating the structure of the lunar crust and mantle 4. Laser Retroreflector Array LRA. It is a passive experiment to understand the dynamics of Moon system 1. Laser Induced Breakdown Spectroscope LIBS, qualitative and quantitative elemental analysis and to derive the chemical composition and infer mineralogical composition to further our understanding of lunar surface. 2. Alpha Particle X-ray Spectrometer APXS to determine the elemental composition Mg, Al, C, K, Ca, T, Fe of lunar soil and rocks around the lunar landing site. 1. Spectro-polarimetry of habitable planet Earth, shape, future discoveries of smaller planets and reflected light would allow us to probe into variety of exoplanets which would qualify for habitability or for presence of life.
जय हिंद, जय भारत।